Alright, then next is we're going to talk about horizontal kinematics, which is the linear problems. We're going to start with the first one again, because it does cover a lot of the components of the stuff that you're, if you choose a different question to do, a lot of the same sample problems are going to be based off of this one. So it says a 747 jet traveling at a velocity of 70 meters per second north. So we know we have a velocity, initial velocity, of 70 meters per second in the north direction. Touches down on a runway. The jet slows to rest, so automatically there I know that I have a final velocity of 0 meters per second. At a rate of 2 meters per second squared. So we have an acceleration of 2 meters per second squared. Now, if the object is slowing down, that means that this object is not positive in acceleration, but negative. So again, you have to read the question and make sure that you understand what it's asking. And so, for number 1, it says to calculate the total distance the jet traveled on the runway as it is brought to rest. Show all your work. So if we go back to our equations, we know what we have. We first have initial, final velocity, and we have acceleration. The one thing that we don't have is the time, but we need to figure out the distance. So if I look at my basic kinematics section, I'm looking at something that has the variables of velocity, final and initial, and also has acceleration, but is able to give me distance. So if I look at this here, the one thing that I can see that has the acceleration and final velocity, and I can find distance. And remember, distance is given by delta x. Y I have no idea, but please keep that in mind. I will probably remind you on the day of the test that delta x is equal to distance. Again, some really odd things. There may be some things on the test that I'll have to give you a little extra just so that you have that information. So delta x is the distance, and that's going to be given to you as here. So vf squared equals vi squared plus 2ax is the equation we're going to use. And I'm just going to put a D where they have delta x. So we can plug in our variables that we have. We know that the final velocity is 0, which is equal to the initial velocity, which is 70 squared, plus 2 times negative 2 meters per second squared, times the distance, which is what we're looking for. So we're going to square 70, and that's going to give us negative 4,900. And we're going to move that over to the left, so that'll be canceled out. And then we're going to multiply 2 times 2, which gives me negative 4. And that's going to also be for our distance d. So we're going to divide by both sides, negative 4. Oops. And that's going to give us a total of 1,225 meters, which is equal to your distance. Now, if you think about that as far as a plane goes and it landing, and it's a 747, that makes a lot of sense. So this would be a correct answer. Alright. Question number 2 on the diagram below. Point P represents the position on the jet on the runway. Beginning at point P, draw a vector to represent the magnitude and direction of the acceleration of the jet as it comes to rest. Use a scale of 1 centimeter, which is equal to 0.5 meters per second squared. So if we have this direction, which is P, we know that the jet was moving in the north direction. So I'm just going to draw it going north. And it is not to scale. So this is the plane going in the north direction. Now, the acceleration, because the plane is slowing down, the acceleration is not going to be in the north direction, but it should be in the opposite direction. So your acceleration should be in the south direction. And your magnitude for that, and it should be about this length, which is equal to -2 meters per second in the south direction. And it should be a length of about 4 centimeters. Okay. Alright, the next question we're going to do is question number 3. So, question number 3 says that we have an observer recorded the following data of the motion of a car undergoing a constant acceleration. We're given the data table. What is the magnitude of acceleration of the car? So we're looking for acceleration again for question number 3, which is change in velocity divided by time. So we have this set of data, and this is pretty much just finding the slope. If you were to graph this out, it's the same idea. But we have change in velocity, so you can choose any 2 points to find the change. Usually a good thing is just to do, obviously, the beginning and the end for the total times. So if you had more data points, you could probably get away with doing less, but for the overall average and change, you want to do start to finish. So that means we have 8.5 is our final, minus the initial, which was 4, and we're going to divide that by the change in time, which is 6 minus 3. And if you notice, this is the same way that you would find a slope. So 8.5 minus 4 and 6 minus 3, that should give you 4.5 divided by 3. And that will equal 1.5 meters per second squared. So your answer should be number 3. Okay. Next is the horizontal kinematics. You did a lab that was over this, where you had your ticker tape timer and you had to measure out the times and graph them. So the first thing is, for question number 6, it says use a metric ruler to determine the distance traveled during the time interval from time equals 0 to time equals 0.3 seconds. Record your answer to the nearest 10th centimeters. So if you measure the entire distance from 0.5 to the end, you would have gotten 13.5 centimeters. And that's the distance that it traveled. For question number 7, you need to calculate the magnitude of the acceleration of the cart during the time interval from time equals 0 to 0.3 seconds. So we're looking for the magnitude of acceleration. So to find acceleration, we have several things. We know that each of the ticker tape timers took 0.1 seconds. We also know that the total distance traveled, this is our total distance, which is had occurred in a given amount of time, which was our 0.3 seconds. So if I'm looking for the acceleration, I do have to figure out what the velocity is. So velocity equals our distance, which is 13.5, divided by the time, which is 0.3. And that should give you 45 centimeters per second for the velocity. And then I can figure out the acceleration very easily. I know that it's 45 centimeters per second divided by 0.3 seconds. And my acceleration is 150 centimeters per second squared. Now, you could have done this the same way by finding the distance between each one, and then finding that each of those distance and velocities were always increasing by the same amount. But this just makes more sense to do. Just to find the velocity and then to figure out the acceleration, it makes a lot more sense. So for question number 8, it asks you the same thing. What is the average velocity? So that's the same thing as this one here. So you should have got the same answer for question number 8. If you did it the other way by actually figuring out the distance, figure out the velocity and the distance between them, you could have figured out the acceleration. But the calculations make more sense just to do it this way. Okay, question number 9 says on the diagram below, mark at least 4 dots in order to show the cart traveling at a constant velocity. So if the cart is traveling at a constant velocity, that means there's no increase. So you should have evenly spaced dots. Okay. The next we're going to go to question number 14. Question 14 says a car increases its speed from 9.6 meters per second. So that means we have a initial velocity of 9.6 meters per second to 11.2 meters per second, so a final velocity of 11.2 meters per second. In 4 seconds. So our time is 4 seconds. The average acceleration of the car during the 4-second interval would be. So acceleration, again, is change in velocity over time. So change in velocity is final minus initial speed divided by the time, which is 4 seconds. So you should have 1.6 divided by 4, and you should have 0.4 meters per second squared. That would give you an answer of 1. Okay, the next question we're going to do is questions 17 and 18. So base your answers to questions 17 and 18 on the information below. A car traveling at a speed of 13 meters per second accelerates uniformly to a speed of 25 meters per second in 5 seconds. For 17, calculate the magnitude of the acceleration of the car during the 5-second time interval. So again, we're going to look at question 17. We're going to look at the acceleration, which is change in velocity over time. So change in velocity, we had gone from a final velocity of 25 meters per second from 13 meters per second. So we're going to 25 is your final minus your initial, which is 13, and divide by 5 seconds. So that should give you an acceleration of 2.4 meters per second squared. For question 18, a truck traveling at a constant speed covers the same total distance as the car in the same 5-second time interval. Determine the speed of the truck. So this means that there's no acceleration for the truck. It occurred at the same constant speed. So to figure this out, you have to know what the distance that they both traveled. So that means we have to go back and determine how we're going to determine what the distance is. So if I go back to my equations, I know I need to figure out what the distance is. I have my final initial velocities, and I also have my time. In addition to that, I also have my acceleration. So we can figure out the distance pretty easily, knowing that distance is based on your average velocity and time. So, however, the average velocity is going to be different for the first car because it had acceleration. So that means the average is going to be a little variant versus the other car. So what we're looking for is how we can determine the distance without using time, which we can do if I use without using acceleration. Sorry, because we don't want acceleration in the problem. So we have our distance can be found by half v initial plus v final times the change in time. So we're going to have our distance, which equals 1/2 V initial, which is 13, plus final, which is 25, times 5, which is our time. So that means that our distance is going to be 95 meters. So the total distance that this car traveled was 95 meters, and that means that that's going to be the same distance for the other car. So for question 18, if the car traveled a distance of 95 meters in 5 seconds, which is our time, we know that the velocity of this car is going to be 95 divided by 5, which is 19 meters per second. Alright, the last question we're going to do for this section is the last one, which is question number 24. A child riding a bicycle at 15 meters per second accelerates at negative 3 meters per second squared for 4 seconds. What is the child's speed at the end of the 4-second interval? So, we have a lot of information. So the first thing is a child riding a bicycle at 15 meters per second. So we know that the initial velocity is 15 meters per second. Accelerates at negative 3 meters per second squared. So acceleration is negative 3 meters per second squared. So we know that the child is slowing down for 4 seconds. What is the child's speed at the end of the 4-second interval? So we want to know what the final speed is for this time. So we're going to do the same thing. Acceleration equals change in velocity over time. Our acceleration is negative 3, which equals our final minus the initial, which is 15, divided by time, which is 4 seconds. So that means negative 3 times 4 will equal V final minus 15. Okay? So that gives us negative 12, which equals V final minus 15. We're going to add 15 to both sides. And that's going to give us positive 3, which equals V final. And so, if it's a velocity, in this case, we're doing 3 meters per second. So your answer's choice should have been number 3. Now, if you didn't account for the minus sign, then you probably would have gotten answer choice number 2. So be careful with that. Minus signs are going to tell you the difference between us going faster or slowing down, and will affect the outcome of your problem. Alright, if you have any questions about any of these, please make sure that you ask during class.